In this exercise, we're asked to graph a relation. And we could get out a piece of graph paper and we could draw out a table of values and fill in some values of x and determine what y is going to be from that. But what we're going to do is we're going to actually graph this on the graphing calculator, which is what you're going to use most often. But then from there, we're asked to determine the domain and the range. We're asked to determine whether the equation does represent a function or not. And if it does represent a function, is it one-to-one, onto, both, or neither? And then lastly, we're asked to state whether the function is discrete or continuous. So we're going to jump over to the TI-84 calculator. We're going to graph this equation, y equals x squared plus 1, and then state the domain and the range, determine whether it's a function, what type of function is it, and is it discrete or continuous. Well, as you can see, we got a TI-84 plus CE calculator pulled up, and I can see from what I was working on last, this is actually what is called a box and whisker plot, so I must have been using the stat plot. So I got to do a couple of things before we graph this equation y equals x squared plus 1. And the first thing I need to do is go in here and turn my stat plot off. So I hit second and then y equals, which takes me to the stat plot. And I can see that plot 1 is on, and so I'm going to move the cursor and turn it off. All right, now also I want to check my window settings because I probably had some bizarre things in there, so I want to get it more back to the default region. So I'm going to hit the window button, and I can see, okay, I got an x minimum of 28.7. I'm going to take that back to -10, which is the default setting. X maximum rather than 56.3, we're going to move that to 10. X scale 1, that's fine. Y minimum -1210. See, I had some large numbers in there. I'm going to change that back to -10. And Y maximum is 6,000. I'm going to go back to 10. And Y scale 1, I'm happy with that. All right, so now I should be ready to graph y squared plus 1. So I'm going to hit the y equal button. I don't have anything in that field. And so I'm going to hit X and then the little square button, plus 1. And let's take a look at our graph. Okay. All right, so we want to think about first the domain and the range. And this is, actually we're in a section of linear functions, but this is not a linear function because it's not a line. This has got more of the U shape, or what we call a parabola. This is characteristic of what the equation told us, which is it is a quadratic equation. And my domain is going to be all real numbers. In fact, if I wanted to go in and look at the table of this graph, I could hit second graph, and it's going to bring up the table. And I can see, and if I wanted to scroll, and I'm not going to do a whole lot of that, I can see that here we're going, looks like we're going out to -infinity, and we'll go back the other way. Same thing's going to be true. So for every value of x, there is a specific y value. Now, another way we could tell that I should look at the range. Let's go back to the graph. And now the range, if I look at here on the vertical axis, we bottom out right here where y equals +1. And so my range is going to be y such that y is greater than or equal to 1. So the domain is going to be all real numbers. The range is going to be y such that y is greater than or equal to 1. Now, is this a function? Well, we can look at the table, but the simplest thing to do is apply the vertical line test. And so if we start visualizing, and I can't mark on this, if we start visualizing, bringing down vertical lines, that vertical line test would tell me that if that vertical line is only going to cross this graph at one point, then it is in fact a function. And so this is a function. And before I get into the one-to-one, on-to, whatever, both or neither, I want to think about, is this discrete or continuous? And one simple way to determine whether we've got a continuous function or not is if I could draw that graph with a pen or pencil, would I have to lift that pencil to finish drawing it? And no, I could just trace right along this graph just right here, and so it is continuous. Now, is it one-to-one or is it on-to? Well, let's see. One-to-one means that each element of the domain pairs to exactly one unique element of the range. Well, that's not going to be true because, let's see, if I had 2 squared plus 1 as an example, well, 2 squared is 4 plus 1 is 5. So there's a distinct element of the domain and an element of the range. But if I looked at -2 from the domain, well, -2 squared is also 4, and plus 1, it's 5. So both 2 and -2 give me a value in the range of 5, so it can't be one-to-one. Now, what about on-to? The definition for that is each element of the range corresponds to an element of the domain. Well, that would be the case. I don't have any numbers in the range that are not corresponding to an element of the range, even though my range is greater than or equal to +1. So this function is on-to. So we got a function. We can apply the vertical line test. It's on-to. It's continuous because we could draw it without lifting a pencil or pen.